Okay, now we will begin the study of the probability distribution. A probability distribution is similar to a relative frequency distribution. However, instead of describing the past, it describes a likely future event. Let's check some concepts first. Random variable. It is a quantity resulting from an experiment that by chance can assume different values. For example, the experiment is we count the number of the students absent from the economics class on Monday. Then the number might be 0, no student, 1 or 2 students or 3 students missing the class. Here the number absent is a random variable. Or let's say we're going to toss 2 coins and count the number of the heads facing up. There could be 0 or 1 head or 2 heads facing up, because the number of the heads from this experiment is due to chance. That is why we call the number of the heads facing up random variables. Go further, there are 2 kinds of the random variables. One is a discrete random variable, the other is continuous random variables. Discrete random variables assume the clearly separated values. Those values are discrete data, right? They are the values from counting, such as the number of the complaints per day, number of the TVs in the household, number of the rings before the phone is answered. On the other hand, the continuous random variable are continuous data, which can take on any value. Okay, those kind of the data or the value are usually from a measuring, such as we measure the thickness of the item, time required to complete a task, or we measure the temperature of a solution, or we measure the height in inches. Probability distribution is we do an experiment and then we list all possible outcomes and then we show the probability of each outcome based on the different random variable, and we have the 2 different probability distributions. One is the discrete probability distribution, the other is continuous probability distribution. We're going to talk about continuous probability distribution in the next chapter, and in this chapter we're gonna focus on discrete probability distribution, which is we list all the possible outcomes and show the probability associated with each outcome. In order to help you understand this better, let's check an example. The example is we're gonna do an experiment that we're gonna toss 2 coins and then we count the number of the heads facing up, and then we display the probability distribution of this experiment. First, we're going to list all possible outcomes. There are 4 possible outcomes. The first outcome going to be you toss 2 coins and both coins are tails facing up. The second outcome might be the first coin tail facing up, the second one is the head facing up. And the third outcome might be the first coin head facing up and the second coin tail facing up. The fourth possible outcome might be the first coin head facing up and the second one head facing up. The random variable here is the number of the heads facing up, so we're going to count the number of heads facing up. 0 head facing up, 1 head facing up, and 2 heads facing up. So from all possible outcomes, let's check what's the probability for each random variable. The probability of 0 head facing up is 1 out of the 4, right? Because there is one possible outcome that is 0 head facing up, and there are in total 4 possible outcomes. So the probability of 0 head facing up is 1 out of the 4. 1 over 4, we get the probability is 25%. And the probability of the 1 head facing up, there are 2 possible outcomes. Out of the 4 possible outcomes is the 1 head facing up. So the probability of 1 head facing up going to be the 2 out of the 4 is 50%. So how about the third? About the 2 heads facing up. there is one possible outcome is 2 heads facing up. There are in total 4 possible outcomes. So the probability of 2 heads facing up is going to be 1 out of the 4, right? 1 divided by 4. So the probability of that is, again, 25%. And then we show the random variables here, 0, 1, and 2, and we show the probabilities associated with each random variable. We display them here, we get the discrete probability distribution. We use the height of the bar to represent the probability, and we can tell the shape of the distribution here, and means the most possible outcome gonna be the one head facing up, so we know where the data concentrate. Here are the conditions that discrete probability distributions meets. Each outcome in the distribution needs to be mutually exclusive with the other outcomes in the distribution. What does that mean? That means this outcome and this outcome cannot happen at the same time. Second, the probability of each outcome must be between 0 and 1. And the sum of the probability for all the outcomes in the distribution must be 1. For example, here, if we sum up the probability of all the outcomes, then we found out the result is 1. 0.25 plus 0.5 plus another 0.25, we get 1. Next, we need to learn how to calculate the mean of the discrete probability distribution. And the mean of the discrete probability distribution is also known as the expected value. Okay, it's a useful formula. The formula is here. The mean of the discrete probability distribution equal to, we sum them up. So this is sigma, this sum, it means the operation of summing up. We're gonna sum up each random variable times its probability, and we're gonna sum them all up. For example, if there are 3 random variables here, x1, x2, and x3, then we're gonna, this formula equals to x1 times the probability of x1 plus x2 times probability of x2 plus x3 times the probability of the x3. Okay, let's check this example to see how we carry out that calculation of the mean of the discrete probability distribution. Here are the random variable xi, right? x1, x2, x3. Here is the probability of each random variable. So that's probability of x1, probability of x2, probability of the x3, and then we do the multiplication of them, right? So the product of the x1 times the probability of x1 is 0. 0 times 0.25. And this one is the product of x1 1 times the probability of x2 is 0.5. So 1 times 0.5 is 0.5. And this one gonna be the product of 2 x3 times probability of x3, that is 0.25. So 2 times 0.25, we get 0.5. And then we do this sigma, right? The sigma, this sum means operation of summing up. We're gonna sum this one and this one up. So 0 times 0.5 times plus 0.5, we get 1. So the mean number of the heads in the 2 flips is 1. Next, let's see how we compute the standard deviation or discrete probability distribution. And first we need to find the variance, because the standard deviation is the square root of the variance. Okay, so here both variance and standard deviation is more of the spread of individual values around the mean of the data set. Formula for variance is like this. Sigma square is the variance of the discrete probability distribution equal to, again, we say this is sigma sum, right? This sigma sum means the summing the items up. So is equal to the each value is random variable minus mu. Mu is the mean of the discrete probability distribution, and square it. Then times each probability of the each random variable. And standard deviation is the square root of the variance. Again, let's use the example to show how we do that calculation. Same examples, right? So here are the random variable 0 head, 1 head, and 2 heads. The probability of each random variable is 0.25, 0.5, 0.25, and the mu, the mean of the discrete probability distribution we got from the previous slide is 1, right? So mu is the same for each one. Mu is 1, 1, 1. And xi minus mu is each random variable minus mu. So 0 minus 1 is minus 1. 1 minus 1 is 0. 2 minus 1 is 1. And then we square them. So minus 1 square is 1. 0 square is 0. 1 square is 1. And then we use the result of this part times the probability of the each random variable. That is, we're going to use the result of this one times this one. So 0.25 times 1, we get 0.25. 0.5 times 0, we get 0. 0.25 times 1, we get 0.25. And in the end, we're going to carry out that summing up operation, right? So we're going to sum those three numbers up. 0.25 plus 0 plus 0.25, we get 0.5. So the variance is 0.5 heads squared. And the standard deviation is taken square root of the variance. So sigma is square root of 0.5, we get 0.707. So the mean and standard deviation are useful when we compare two different distributions. For example, we're going to compare the number of rings before call is answered from the Atlanta and Boston call centers. Those are the data we collected from the two call centers, right? The number of the rings, those are the random variables, and the probability for each random variable. After calculating the mean and the standard deviation for each center, we got the result. So mean for the Atlanta call center is 3.15, and the standard deviation sigma is 1.2, and the mean is 1.9. Sigma standard deviation is 0.8 for the Boston call center. So what does this mean? Means the Boston call center has a lower mean. Okay, lower mean, that means it's a faster average answering time, and it's more consistent. Why? Because the standard deviation is smaller. Standard deviation means that each value, how far each value, on average, how far each value away from the mean number. So this standard deviation is smaller, means the most of the data is closer to the mean number. That means their services is more consistent. Okay, another application, we just mentioned that the mean of the discrete probability distribution can also called expected, right? Expected value. So here, expected monetary value is the mean of a discrete probability distribution when the discrete random variable is expressed in terms of dollars. We call that EMV. So EMV represents a long-term average as if outcomes from distribution occurred many times. For example, here is a calculation of the expected monetary value for profit from a crop yield. There are three different kinds of situations: dry weather, light rain weather, and the weather with a storm. And for each situation, there are the profit level, right? $200,000 when the weather is dry, and they can gain the $300,000 profit level for the light rain weather, and the profit level of the 150,000 when the weather is storm, and the probability with each the random variable. Okay, how do we calculate in the future the expected monetary values? That means the mean discrete probability distribution here, right? So EMV is equal to the mu equal to the sigma from 1 to 3, right? Xi times the probability of xi. So that equals 200,000 times 0.3 plus, say sigma sum, plus 300,000 times 0.5 plus 150,000 times 0.2, the probabilities. So the result is 240,000 US dollars. That is expected monetary value, expected average profit for this crop field for the future. Okay, so if you have any questions, please let me know. And again, email is always the best way to find me. Thank you.